Hello, my name is Masen Reid,
Hi, my name is Javeiria.
and today we're going to go over Group Assignment 1 from Dr. Rizk Data Structures class. So first, before tackling this group assignment, y'all should be comfortable with stacks, infix, and postfix, and linked lists. So here's some main ideas on how to approach these group assignments or even homeworks. First, you need to read over the homework very carefully. Second, you need to analyze what the homework is asking of you. Third, you're going to parse through the file and sort through information. Fourth, you're going to code necessary functions in the remainder of the assignment. Fifth, you're going to check your work. Sixth, upload to server. And seventh, make sure you have passed each test case on the server.
So it's important that you read the assignment instructions as soon as they're posted, because this gives you an ample amount of time to think about what to do or where you might need help. And you can reach out to TAs early and not the night of the assignment's due date. And refer back to the lecture notes and weekly labs for ideas to help with the homeworks.
So right now, if you haven't read the directions already, you should pause this video and take a couple minutes to read over the directions. If you have, you can let the video continue playing and we're going to go over what you just read. Okay, so now we're going to analyze the directions. So far in this PowerPoint, you see two columns. You see the what you read and what it means. So we're going to break down the homework instructions into terms of how we can start to think about coding it. So in the directions, you read that each line is one expression. And this means that we're probably going to use the while and the get line to parse through the input. It also says first check if expression is valid or not. So this means we need to check if there is a closed bracket and parentheses for every open bracket and parentheses. We're going to keep count on how many invalid expressions they are. And by doing that, we're just going to have a counter, which is very self-explanatory. We're going to decode the expression, and we're going to decode the expression by evaluating the expressions given to us and using that value and putting it into a list. We need to make 4 separate linked lists, and the 4 are going to be one, Travis's linked list for his decoded values, another one for Scarlett's linked list and her decoded values, a third one which is going to merge them together, and then the fourth one will be the passcode given to us on the input. We also read about the result of a valid expression gives a number, and so that's just saying once we evaluate the postfix, which we have to get from the infix, we can store this number into a linked list. And if the value is positive, then we're going to add it to the list. However, if it's a negative number, we need to find the positive counterpart and delete that from either decoded list. So that means if we find out that Scarlett had a -2, we need to take out a 2 from either her list or Travis's list. Okay, and then here's just a couple more things. We're going to get the decoded passcode, and at first it's going to be out of order. And so first thing we're going to do is just merge the two lists together, which is going to be Scarlett's linked list and Travis's linked list. Then we're going to get the decoded list in order, and that means we're just going to sort the merged list. We're also going to delete values based on the invalid expressions. So the count that we had set earlier, we're going to use that number to delete that value or that position.
That value at the corresponding position.
Yeah.
The list.
Thank you. And then lastly, we're going to print out the correct information based on the answer that have been provided.
The next step would be parsing, in which you would get the names, the expressions, and the decoded passcode. And so to get the names, you would use if statements to get Travis and Scarlett, and the expression you would use get line statements for the rest of. everything else, all the other information. And to begin coding, you would need to evaluate, you would need to see what you need to do to, like what you need to code. So you would need something to evaluate the expressions, and then also compare if the actual decoded passcode matches the decoded passcode list that we got from the original file. So in order to evaluate the expressions, you would need to change infix to postfix and then evaluate it using the postfix. And then you can compare the two linked lists by iterating through each value in one list and comparing it to one another. To evaluate the expressions, you'd probably need around 5 functions: infix to postfix, evaluate postfix, operation, PEMDAS, and isValid. So infix is when an operator is in between every pair of operands, and postfix is when an operator is placed after the operands. And so infix to postfix will change the original expression, which is given in infix, to postfix, so that we can evaluate the expression in postfix. The operation function will be used to see whether the element at that position is a number or an operation. This affects what gets added or popped from the stack. PEMDAS is going to be related to the priority operation, and so plus and minus is going to be a lower priority than multiplication and division. The isValid function checks whether or not there are the correct amount of open and closed brackets and parentheses, and so this will probably be a Boolean function.
We have a couple more functions that we might need for this assignment, and they are the compare list, delete position, remove value, insert at end of linked list, sort, and print list. And here's some reasons why we need these. So for the compare list function, we will be comparing the actual passcode we computed from the postfix and the passcode given from the input file. The delete position will remove the value at a certain position in the final merged decoded linked list. Remove value will remove a value in either person's linked list, so Scarlett's or Travis. Insert at the end of linked list will add values that were received after evaluating the postfix function into the linked list of the corresponding persons. And sort is just sort. Lastly, we will print the information that we have received. So after we have coded, we will obviously check our work and make sure everything's correct and printing out correctly. And then we will upload to the server, and then we will check on the server that we have passed all the test cases. So at this point, we can open up Rappel and get ready to start coding.
Code that we have for the group assignment, and we're going to walk you through it. At the beginning, they're just the libraries that you would need, that we need basically for every assignment. And then at line 8, there's argument manager, which you also need, so it runs in the server.
Okay, so let's get started. The first thing we need for linked list are the structs for nodes, and we've gone over this in class many of times. For the node, we're going to need the integer value, the node next, and then we're going to initialize this. So as you see, we have the int v equals the n equal to null printer, and then the value v, and next n. From there, we're going to move on and create a class called linked list. So some of the members are going to be private and others are going to be public. All of the functions will be public, while some of the objects like integers and the struct will be private. So we have the node head, the node tail, and the insize as a private member. And some of the things we have as public is, of course, us initializing the linked list, setting head equal to null, tail equal to null, and size equals 0. We also have the node get head, which we will need when referring back to Scarlett and Travis, and as well as the merged linked list. We're going to go into our first function with parameters called node delete position, and this is going to take in the node head and in position, and Gia will explain this one.
The first thing we're going to check is if the position is negative, it's just going to return the head unchanged. And the next thing we're going to check is if the head is empty, like if that linked list is empty, it's just going to return null. So if the position is equal to 1, we're going to create a new linked list and set that to the next value in the head. And then we're going to delete the head and return that list. And then after that, we're just going to use recursion, and for the head next, we're going to use delete position, head next, position -1, and that's going to keep going through it until it deletes the right value at the right position, and it's going to return the head after doing all of this. Next is a Boolean function called remove value, which has the parameters of previous, node star cu, which is current, and int value. So at first it's going to check if cu isn't equal to null and return false, and then if otherwise it's going to check if the value at cu is equal to the value that we're given in the function, and so if cu is equal to head, so if that's where it's equal to the first value, then head is equal to head next. Else previous equal to next is previous next is going to equal to current next, and return true. Else otherwise it's just going to keep going through the function, and it's going to return remove value, current next, and value until we're done with the function. And so the Boolean remove is just going to use the function above as it's going to be what we use to call function in the main CPP. Do you want to? Mason's going to show you how to do the insert functions.
Okay. So just like above, for the insert, we have kind of two functions. One's going to be used in the main, and one is going to be just right here in the public area. The insert, and you're going to take the node current and the data, which is given in the main, as you can see down here in line 83, the value. And what you're going to do is you're going to make a new node called temporary, and you're going to set that to null. If the current is equal to null, then the head and tail are both equal to temporary. If else the current arrow next is equal to null, then the tail arrow next will be equal to the temp, and then the tail will be equal to temp. And then else, we're going to say insert at end. So this means it's just going to repeat through these three statements until it's finished. When we move on to the add function, what we're doing is getting that value that we've inserted from the input file and running it through this function, and then it's going to be put into the insert at end. And then we're going to increase the size. Okay, now we're going to go over the sort list.
So for sorted list, we're gonna create a new list that's equal to null. That's gonna hold the sorted list at the end, and then we're gonna create a pointer to a pointer of a node that's going to help us traverse through the list, and then another one that holds the largest node, and then a pointer to a pointer for largest node, and then we're gonna create on line 91. We create a list that holds the largest node. So we're going to create a while loop that goes through the list that we pass as a parameter. And then while that's not equal to null, it's going to do all these things. And so the node, we're going to set node pp largest to plist, and we're going to set pp node to the next node in pp largest. So and then we're going to do a while loop where so that's going to keep going through the list until pp node is equal to null. So that's just going to help us traverse through the list, and that's going to check on line 96. It's checking if the value is greater than the value in pp largest, and if it is, then pp largest we're going to set pp largest to pp node, and then move pp node onto the next node. After that, that's going to exit that while loop, and we're going to set p largest to pp largest, and that's going to move the node to new, and then move pp largest to the next of p largest, and p largest to p new, and then we're going to set p new to p largest, and in the end we're going to return p new, and that's how we're going to sort the list.
And we just want to mention that there are multiple ways to sort linked lists that we went over in class. There's the bubble sort, merge sort, insertion sort, quick sort, you name it. So there's more than one way to sort the list. And this also goes for inserting it into a linked list, a value into the linked list. You can insert at the end, you can insert at the beginning. There are multiple ways to do this. Now we're going to go over the merge list. So at this point, this is going to be when we want to get the decoded passcode, and this is going to take Scarlett's list of values and Travis's list of values, and we're going to merge them together and return that. So in this function, we have the x, node x, and then node y. So if x equals 0, basically if Scarlett's is equal to 0, then we're only going to return Travis's, and if Travis's list is equal to 0, we're going to return Scarlett's. So if that's not the case, then we're going to make this new linked list that is merging these two together. And then we're going to create another linked list that's going to traverse through the next from the Z, which is right here, which we initialize right here, and Y. So all this is doing is merging this into Z, which we are going to return, which will be one linked list that is both Travis and Scarlett's put together.
So the last function for the linked list is going to be printing the list to the file. And so we're just going to use a for loop to go through the list until the end, and we're going to output the next value. Output the value, and then that's it, and end it with one of these brackets. And that we're going to do the same thing for the curly braces, and then the same thing for these brackets.
Okay, and then lastly, for the last else statement, while the stack isn't empty and then the priority on top is greater than what's inside the priority of the element that we are on through the for statement, the ni, then we're going to add it to the top of the stack, and then we're going to add it to the post fixed string, and then take it off the top of the stack, and then we're going to push the element that's here onto the stack, si onto the stack. And then while the stack is not empty, as before, we're going to put the top of the stack onto the string, and then we're going to pop the stack, and then finally we're going to return the final string, postfix string. For the next one, it is a Boolean of checking if the expression is valid. So for this one, we need a stack that will be full of characters, and we're going to call that stack S. We're going to need a for loop to loop through all of the characters in the string. So that's where we get in line 276. So character X is equal to the first string, the first character at the string I. And if X is equal to any of the opening parentheses, bracket, or curly brace, we're going to push it onto the stack. If it's equal to the ending parentheses, bracket, or brace, then we're going to check if it's empty, and if it's not empty, it's going to be false. This means that the parentheses, bracket, or brace was never closed. So this is an invalid function. Now, if you find the closed parentheses and the top equals the opening parentheses, you're going to pop from the list. And this continues for the bracket and brace, curly brace, and then this function or this character as well. And you're just going to pop from the list. Now, after you do all of these, you're going to check if the stack is empty, then you're going to return true, meaning that they've taken off all of the pairs, meaning this is a valid function. If not, if the stack is empty and we have, say, 2 ending parentheses, then that means that this is not a valid expression and you will return false.
This is just another print list function that we're supposed to use to print out the individual list for the twins. So for Travis's list and for Scarlett's list, this is the print function you would use, and then for the final list, you would use the one we mentioned earlier. But it does it in the same way, where it goes through, where it traverses through the list, and then outputs it to the file.
Next, we have another Boolean function called compare list. And right here, we'll be comparing the actual passcode given on the input file and the decoded passcode we got from computing the infix expressions. So right here, we pass in 2 linked lists, which I just told you about. And while the linked lists are not empty, we're going to check each value. So the first value of the decoded passcode of the input and the one we computed. If they do not equal each other, then we're returning false. So this means that they are not the same. Now, if the first elements are same, that's a good sign. We're just going to go ahead and check the next elements. And we're going to continue to do so until both linked lists are empty. Now, if the linked list is not empty, if linked list 1 is not equal to 0, or linked list 2 is not equal to 0, then we're going to return false. This means that one finished before the other. Else, we're going to return true. And this completes all of the functions we will need for this assignment. Okay, so now we're going to get into the main function. But before we do that, we need to make another struct called stack type, and this is going to hold a value and a string name. We're going to get a little bit into this later when we use it, but the value is going to be the negative value that we need to remove from the list, and the name is going to be whose list it needs to be removed from. So we're going to go ahead and get into the argument manager and the string in file name, and the lines you see right here. These first 5 lines are pretty much going to be the same for every homework and group assignment you do. As you see with the IF stream input file and the parentheses, when testing it and debugging, you would want to put in input file 11.txt or whatever input you'd like to work with to make sure everything works. After that, you see we have initialized 4 linked lists. 1 for Scarlett, 1 for Travis, 1 for Together, and passcode. The first 2 are pretty obvious of what they're for. The third one is going to be the merge linked list of Scarlett and Travis. And then the fourth one is going to be the passcode given to us in the input file. So from there, we have some more things we initialize. We have strings as line, passcode, name, expression, postfix, and P1. And in integers, we have value and valid count equal to 0. And then we have a stack of stack type for neg. And I talked about this a little bit briefly before. Now, when actually parsing, we're going to use getLine, and then from there, we're going to use the input file variable, and then the string line. So this is going to give us the entire line. Now, if the line is empty, we want to continue and skip over it. After we do that, we need to check if the line is starting with an alpha, so if it's a letter. Now, if it is equal to passcode, and we would know that by using a substring through 0 to 9, and if that substring of line equals passcode, then passcode is equal to the line substring 9, which is where it ended, to the rest of the length. So this is going to get everything after the passcode, and we're going to store it into the value variable passcode. So from there, we're going to do for int I equals 0, I less than the passcode size, and then we're going to loop through each value. P1 is going to be equal to the passcode at value I. Then we're going to initialize a new integer u, and we're going to use stoy, which is just going to turn this string into an integer. And then lastly, we're going to add that value into the linked list passcode. Now we're going to do this so that we can check if the passcode is the same as the decoded passcode we get once evaluating the postfix expression. So after we do this, we're going to continue. We're going to take the name and equal it to line. And then from there, we're going to continue as well. So, and then G is going to talk about the invalid, is valid expression, and so forth.
And so otherwise, we're going to set, so if it's not an, like if it doesn't start with an alphabet or a letter, we're going to set the string expression to line, and then we're going to check if the expression is valid. So if it's false, we're gonna increase the count and then continue, and we're gonna do postfix. The string postfix is gonna be infix to postfix expression, and then string value is gonna be the evaluation of the postfix string earlier. And if the value is less than 0, or if it's negative, then we're gonna create a new stack type called negative. And we're gonna next stack type pointed negative, and then we're gonna set that to we're gonna initialize that with the value and the name that we've been just evaluating. So if, for example, if this was throughout Scarlett's, then we would set Scarlett's name or Travis's, and then we push that onto the negative, which is a stack that we initialized earlier. So if it's not negative, and if the name is equal to Scarlett, we're going to add that to Scarlett's linked list. And if it's not negative and the name is equal to Travis, then we're going to add that to Travis's linked list using the add functions that we created earlier in the linked list class. And then we're going to create a while loop with the size of the neg stack And we're going to create a new stack type and make that equal to the top of the next stack. And so if n.name is equal to Scarlet, we're going to remove and if it's not, and if that value is not in Scarlett's list, then we're going to remove it from Travis's. Otherwise, if it's the else statement says that if the n.name is equal to Travis and if the value is not in Travis's list, we're going to remove it from Scarlett's. If it is in Travis's list, then it's going to remove it from Travis, and it's just going to pop. And then at the end, it's just going to pop it off of the next stack, and it's just going to keep going until the stack is empty.
And then lastly, we have trying to get the actual decoded passcode. So at this point, Scarlett has her final decoded linked list with her values, and so does Travis. So at this point, there's nothing else to do for their linked list individually. So now we have also the passcode P that we got from the input file. So we're just going to output these statements, Scarlett, and then her list, and Travis and his list. And here are the functions we've already talked about earlier, print list, that we're going to use. Then we're going to merge together Scarlett and Travis. And we see this in line 428. So in doing so, we create another node called merge head. Now, merge head is going to equal together dot sort list merge head. So now at this point, this is us sorting the list, because prior to this, Scarlett and Travis had unsorted lists. They were out of order. Then we combined them and they're still out of order. So now once we have the merge list, we're going to sort them. So after having this sorted list, we're going to use the invalid count. It says if invalid count is greater than 0, then we need to delete that position in merge head. And we've been keeping count of these earlier in the main. After that, we're going to output the decoded passcode, and to do that, we're just going to use together.printlist, which are functions that we've already created, and we're going to pass in the output file in the merge head. Then we're going to do the actual passcode, which is the passcode.printlist, and we're just going to print out what's in the actual passcode. And then we're going to say if the treasure is unlocked or not, which it is. And so, and if y'all would like to see how this runs, you can always switch out these variables for the input file names.
So we're just going to show you what happens if you put in input 11, 2, 3, and then have it create a file to output that answer to. And then run that. So input 11, this is what input 11 looks like, and this is what your output is going to look like, where it shows Scarlett's list, Travis's list, and then the decoded passcode and the actual passcode. And since they're the same, it's going to say treasure unlocked. And you can see that it's the same as the answer that we were given in the files with.
And so you're going to want to check this with each input. So input 11, 12, 13. And once you have done so, you have to change back all of these hard-coded variables back to input file and output file. You're also going to uncomment out the argument manager in the header if you did comment that out. And then you would need to put this onto the server. And then from there, make sure you do test that you pass each test case.
And that should be it. That should be the end of your assignment. Right?
Yes. Thanks for watching.